Okay, just we're waiting 1 minute, then we'll start the session. Okay, so we will start today's session. So I hope all of you already get the previous materials, mainly the previous session also get the practice code. Okay, so after completing the 3 hours live training, then we talk about the problem solving class for the previous day. Okay, so let me share my screen. Okay, okay, can you see my screen? Is it visible? Okay, thank you. So let's go start. So basically today is our third number class. So today I discuss about that how to calculating any indices. So in the remote sensing we use different types of indices to extract the different types of information from satellite imagery. So Landsat, Sentinel, this type of satellite imagery we are use and calculating the different types of indices. We will discuss about that. And we'll also discuss about that how to filter and displaying the satellite images Sentinel 2 for the different season. Okay, suppose for the specific time period I want to display the satellite image for the different season, suppose rainy season, summer season. Okay, how we can easily filter the data or image collection by season wise, and further how we can easily monitor the water body or vegetation indices. We'll discuss about that, and how to extract the water body from the satellite imagery we also discuss, and how to make the time series chart from Landsat or Sentinel imagery, and then how to make the annual time series chart or monthly time series chart for the different types of indices, and how to export the shapefile from Google Earth Engine. And also we discuss about that how to add the gradient legend and title on Google Earth Engine, and how to make the flood mapping using the Sentinel-1 SAR data, as well as how to compute the monthly time series chart for the different types of indices. So let's go step by step. I try to complete all of those, then I hope you can easily get the idea. Okay, so let's start. So let me open a code editor. So first of all, how we can easily filter the satellite image for the seasonal. Suppose I want to filter the satellite imagery for the two season, for summer season and rainy season. So for that, first of all, we need to import our satellite imagery. It can be Landsat or Sentinel. You can use any satellite imagery. There is no, all of satellite images are the same process. Okay. So first of all, simply import a satellite imagery. It can be Landsat or Sentinel. Same process. So let me import a Sentinel-2 satellite imagery. For that, just click on the browse data catalog and then open the Sentinel section. So here we can easily find out all of Sentinel-2 image collection. And if you check, this is Sentinel-2 multispectral instrument. And here we find out that all of, so in this time we are just use the surface reflectance. Just click on here. So now I can get all of information about that Sentinel-2 multispectral instrument level 2 surface reflectance. So this dataset available between this time period 2017 from 2025 29 November. This is the last time period. And this dataset provided all of information you can get from here. You can see this is the Earth Engine snippet ID for this image collection, and all of bands, reflectance band we also find out in here. And also you can see the image properties. Okay, so now this image collection I need to import in our code editor. So for importing, just copy the snippet ID. So similar process, just I copy and then paste in this code editor. Okay, then just give a variable name. Before the variable name, just use the var keyword. Then we put any name. I put the name, suppose image collection or image this name. You can put any name as a variable. So now this is my image collection. This image collection I want to filter for a specific region of interest, suppose Dhaka city boundary or any specific geometry or polygon. So let me import my study area. So which area I want to work. So in this case, suppose I want to work for a specific boundary. So here I already import the shape file, mainly polygon, for my specific boundary. Or you can also use the POW or also use the US website. This type of data source you can also use as a boundary. I want to work, suppose Dhaka city boundary. So this is my study area. I simply import. And I put the variable name as it's a table, it's a default variable name, but if you want you can also change it or don't change it, there is no problem. I change it. Suppose I put the name as the RY. You can put any name as a variable. So now in this case I simply import my image collection and also import my region of interest. So now first of all I need to filter this image collection where you need the image. So I need the image for the Dhaka city boundary. For filtering where, we simply use a function. We already discussed about that. It's called the filter bounds function. Okay, filter bounds with my study area. Just I put the RY. So this is my Dhaka city boundary. I simply import. Then suppose how I filter. Suppose I need the image less than 1% cloud cover. So for that we simply use that function filter metadata. If you want you can use here the filter metadata, or if you want you can also use the another function. We already know about that. It's called the dot filter, then Earth Engine filter dot less than. Okay, so same. So just put the image property name. So in this case this image property is I want to use suppose cloud pixel percentage. Just I copy and then paste here, and it's a string mainly group of character. So for that must use the quotation start and end because it's a string. Then I simply assign the value, put the comma sign, I take the value suppose 1. So now I simply import where I need the image. I just filter. Then how I need the image. I need the image. This image will be not more than 1% cloud cover. I simply choose it. Then when you need the image. So in this case, it's a time period. Suppose I need the image in year of 2024. But further I also filter for rainy season and summer season. Or suppose I need the image. Suppose from 2015 to 2025 all of year, but I need only for the summer season or rainy season. So first of all you can simply take the whole year. Suppose I take the image from 2024 1st January, from 2024 December 31, or you can put suppose year of 2020 2024. Suppose I take the all of year. Okay, first step we simply take all of year, and further I need to also filter for a specific month or a specific season between this year 2020 to 2024. Suppose 2020 to 2024 I need only for summer season, or I need only for the rainy season, or any specific season. So for the first step we just simply take the whole time period. Understand? We simply take the whole time period. We simply take the whole time period 2020 to 2024. Okay, we take the whole time period. Or suppose I need for only 1 year. Suppose I need the result only 1 year, different season, or only 2 year, 3 year, 4 year, whatever you need. You can simply mention the time period, mainly year. Suppose in this case I just take only for the 1 year. So for this 1 year I simply filter for two season. Suppose summer season or rainy season. Okay, so now if you check how many images, I want to check it, how many images is available. Just I call the image collection and then apply the size function. Okay, and run the code. So now it's computing total 25 images. Okay, we find out this 25 images is available between this time period, and this 25 image is less than 1% cloud cover, and this 25 image is available for my region of interest in Dhaka city boundary. Now I want to filter this image to season. Okay, suppose dry season and also wet season. So first of all, suppose dry season. So how I can filter it for dry season? So take a variable. Suppose I put the variable name is that dry image collection. I just put this type of variable. You can put any name as a variable name. And now I want to filter. So where I filter? So this 25 image is stored in this variable. Just I copy and paste here. Just I paste here. And now we need to use a function. This function called the date range function. If you simply check the function in here, date range. So date range, e.date range, if you check date range, so you can see the start, end, and time zone. Okay, as well as you also use the another function. It's called that calendar range. If you simply check, or I simply search here, suppose calendar range. If you check this function, so e.filter.calendar range. So in the calendar range, suppose we simply return a filter that passes if the object timestamp. Suppose I simply put the start month and in month I put the field, suppose month. Okay, field basically unit. It can be day, it can be year or month. Okay, you can see the argument. Start integer value, end integer value. Okay, and field day of the year or month or hour or minute. So different field we are also using here. So in this case we just filter for seasonal. So we simply choose the month. Okay, so just I use this function ee.filter. So further simply use here the filter function and then write the function ee.filter.calendar range. So now I have to put the calendar range for the dry season. So just you can simply mention the month. Suppose I mention the dry season. It starts from January mainly number 1 month, and then suppose January, then February, March, April, May, June mainly 6, or any specific month you can mention, no problem. And then put the comma sign and then put the unit. So in this case unit is the month, so just put the month. So now what happened? So now in 2024 for the 1 year I just filter it only for the specific month. Suppose January to June I simply filtered. So now if you check, just print this dry image collection, just I copy and then use here the dot size function. So now it find out how many images are available between this season. Just run it. We find out the 15 images. Okay, so this January to June. So in this season, in this month, for the 1 year 2024, we find out that 15 images. This is our dry image collection, dry season image collection. So same, we are just apply the another, suppose wet season or rainy season, suppose wet season. So how we can filter? Simply just apply the same process. Take a variable, I put the variable name, suppose wet image collection, then call this full image collection because it is stored the total 1 year. Just paste here, then filter, apply art engine, filter dot calendar range function. So now you can simply mention the specific wait season month. So in this case, I just put the month, suppose start from the July to, I put October. Okay, July to October, and then put the unit. Unit is the month. So now let's check how many images is available in the wait season. Just I put the print and call the variable name wait image collection. Yes, please. Question. Yes, please. Any question, please?
Okay, I just wanted to comment about the seasons. Isn't this the other way around?
So it's different. So I just write the code for the perspective of Bangladesh. Okay, so for your own country or own region, you can simply find out for the season, rainy season, summer season, or winter season. So different season, it's just only for the perspective of Bangladesh. I just write the code for the Dhaka city. So in the Bangladesh, we find out the on the dry season this month, this January to June, then July to October. Okay, so just we can, when you work on your own study area, try to find out what the season. Okay, which month to which month, then just write it. It will be okay. No problem. Yeah. So now we find out, just we simply filter, and now I want to check how many images is available in the wet season or rainy season. Just run the code. So in this case, if you check, it show the zero. Zero means that in this season, basically July to October, for my study area, there is no image less than 1% cloud cover. So that's the reason I find out the zero, because it's a rainy season. In the rainy season, basically we find out the cloud in the sky. So for the region, you don't find this type of less than 1% cloud cover image is not available in our study area. So it creates one kind of problem. So for that, we are just simply increasing the cloud level. It less than 1%. Suppose I put the less than 3%. Now let's check what happened. Just run the code. Because less than 1% image is not available in the rainy season in the Dhaka city. So for the region, I simply increase the time cloud level. And now let's check. So it's working. Okay, I think some networking issue. That's why it takes some time for loading. Yes, please. Any question, please?
Wanted to find out when you images, is the whole length of the
Okay, just kindly wait some time. I let me check my net connection. Okay, I think some problem. Just a minute. Just a minute. Just 1 minute. Let me check my connection. It just creates some problem. Just a minute. Just a minute. Okay, just coming. Just a minute. Okay, so now I hope it will be okay. No problem. So we continue. Yes, please ask the question again, please. Yes, please again.
My question was that for the first computation you recorded in, that made it for whole rate. And my second question
Okay,
is there a limitation for the cover percentage? And maybe
okay.
to maybe up to 3%.
Okay, it's buffering sometime. I don't clear you. Well, kindly write the question in the chat box. Okay, it will be more better. I think it's a buffering sometime, and voice is not clear from my side. Okay. Kindly write your question in the chat box, please. Okay, just a minute. Okay, speed is okay. It will be working. No problem. Okay, so now I hope you can hear me properly. Yeah. Can you hear me? Hello. Yes, I think some networking issue or buffering some time. I cannot hear you properly. Just a minute. Let me fix it. Okay, now can you hear me? Or is there any problem?
I
Okay,
can hear you.
okay, so now we'll start. I hope it's okay, no problem. Okay, so if you check, we find out that we filtering the seasonal two season, dry season and wet season, and we find out there is no image. Okay, for this season, it means that for this season there is no image less than 1% cloud cover. So for that we simply increase the cloud level. Suppose I put the less than 5%. So now let's check what happened. Is there any image less than 5% is available or not for this season? We try to check it. Also there is no image. So I put suppose 10% cloud less than. So now we find out the two images we can see. Okay. So this is the process for filtering. Suppose now in this case we are just working only for the 1 year, only for the 2024. But suppose I have total 10 years or 20 years image collection. So now from this 20 years or 10 years image, how I can filter for the seasonal. So the same process. Okay. Suppose I just work only for this specific season. So it's a perspective of Bangladesh. So this is the season January to June for that dry season, and then July to October for the wet season or rainy season. Okay. So just I put this type of season. You can also add the mode season similar way. Okay, just for filtering the different season. Okay. So now any question you can ask me please again. Okay, previous time I don't. Yeah, please,
Yes, I have a question.
please.
Why do they have to filter at all for the clouds? Why Google Earth Engine doesn't know that it only supposed to give us images that are not cloud covered? Because, like, I mean, obviously, no one is looking for clouds, right?
Yeah. So basically, this type of cloud, we can find out the all of level. Suppose for a 100% to 1%. Suppose some place or some scene or some image, we all time we find out the cloud. Okay. Basically, for the rainy season, for the cloud, we find out that. So this type of cloud, suppose when you filter, we always try to find out the low cloud level, less than 1%. But if some place or some season there is no image, suppose less than 1% or 2%, then we need to increase the cloud level, suppose up to 10%, 80%. But this type of cloud is also affected your result. So for that we also need to learn how to remove the cloud after adding this type of cloud level. So inshallah, in the fourth number days we will discuss
Okay,
about that.
maybe
Yeah, yeah.
sorry, General, but maybe let me rephrase my question. What
Yeah.
is the most acceptable? What is the least acceptable cloud level? Is this 2%, 5%, 6%?
Okay, so basically it's
At which percentage
it's
not
depend
work
on the
with the image
region.
any longer?
It's depend on the region. Suppose some region is not available less than 1%, but we always try to keep our image neat and clean. We always try to take the neat and clean satellite imagery. Okay, we always try to find out the lowest cloud cover imagery. This is our main target, to find out the lowest cloud cover imagery, less than 1% or 0.1, 0.2, 0.3. We always try to find the lowest cloud cover imagery to get the more better result. But some place less than 1%, 2%, 3%, 4%, 5%, or 80%, there is no image. Then we need to increase the cloud level. Otherwise, we always try to take the lowest cloud cover imagery for our study area. Okay, but when you add the this type of cloud level, when you increase, suppose if I just put the 80%, 90%, 20%, then I find out some cloudy pixel on my satellite imagery. Okay, so when I increase the level, then I find out some cloudy pixel in my satellite imagery. So this type of cloudy pixel we can remove using the cloud mask function. Okay, and these things we discuss in the fourth number days, how to remove cloud and haze from the Landsat and Sentinel imagery. Okay, but we can remove this type of cloud, no problem. Suppose I add 80%, I take suppose 100% cloud, all of image for the 100% cloud, but this type of cloud we can easily remove, and get the very neat and clean satellite imagery. So this process, inshallah, we discuss about the 4th number test, then you can easily get the more better idea how it will be work. Please, any question? Yeah. Yeah, question please.
What happens when you apply the cloud cover? What happens to that image? Because obviously you are taking out some of the data out.
Yeah, I will explain in the 4th number test. Okay, I will explain about the 4th number test, how to work to remove the cloud and get the very neat and clean satellite imagery using the cloud max function. Okay, then you can get the more better idea. No problem. I will try to explain. So now this is the process for seasonal, how we can easily filter for seasonal image collection. I hope you can easily get the idea how to filter the seasonal image collection. This process you can easily apply for any image collection, not only for the Sentinel, Landsat, Modis LST, Modis NDVI, any image collection. When you suppose you need the time series chart for the rainy season or dry season, so any specific season, just apply the same procedure to create the image collection. So just apply this. Suppose for the Modis LST, you need the rainy season LST. So just apply this type of process. Okay, for filtering the rainy season LST image collection or dry season image collection for LST. Same process we can apply for any seasonal filter. Okay. So now I find out these two season, suppose dry season and wet season. So now I want to use this type of image and create the image composite. Okay, suppose take a variable. I want to create the median composite. So take a variable, suppose dry image. Okay, just a minute. Dry image, and call the dry image collection. And then I create the median composite using all of images, and then clip with my study area, suppose RY. So same process, take the another variable, suppose wet image, and then I call the wet image collection. From the wet image collection, just create the median composite, and this thing just I clip with my study area, which is RY. Okay, so now ask the question please. Yeah, any question please? Yeah, any question?
Yes.
I want to find out.
Yeah, please.
Sorry.
Okay.
Okay, continue please.
I want to find out, is there a minimum number of images required for analysis? Like, do you have a minimum number of images required for a certain analysis?
So there is no limitation. Suppose if you have only one image, they can also make the analysis. No problem. Okay. Minimum image, suppose just only one image, they can make the analysis. There is no problem. Okay. Basically, it's different on the image. Suppose if I increase the cloud level, suppose 20%, then I find out the more image. Then this number is also increased. But now I can get that less than 10%. I find out the image in the rainy season. So then I just work with that. Suppose if I don't find the less than 10% image is not available in this season, then I simply increase 20%, 30%, 50%, and then check how many images. So now I find out the two images. So just I use it and make the composite, median composite. Yeah. Yeah. Any question, please? Yeah. Any question?
Sorry. The voice broke up. I didn't hear. I how many images? Let's say, is there a step like, let's say analysis? Do you need one images or 10 images?
Okay, don't get you. Your voice is breaking.
Did you hear my question?
No, I cannot hear you.
Breaking?
Yeah, please.
Can you hear me now?
Yeah, please repeat the question, please. Yeah. Yes, repeat the question, please.
Can you hear me now?
Yeah, I can hear you.
So what I was saying, let's say for mineralization spectral analysis, do you just need one image, or you need two, or you need 10? What is the best practice, or is there a standard
Okay.
protocol?
Yeah, so we try to take that, suppose our just create the composite. So one image, a single image is more better for the mirrorization. Okay, so a specific time period, but it's very rare because some players we don't find out the for this imagery. So then we need to combine and create the composite. But for the one image is more better for that mineral exploration. Okay, to take.
Thank you.
Yeah. So let me just add the layer. Suppose map.add layer. Map.add layer. And call the try image. Okay, so now I run the code. It's added to the layer, but not focus my given study area. I want to focusing map.center object. Object is suppose RY. Zoom level is a 10, and then run the code. So now we find out this type of imagery. Okay, so this is the dry imagery. Yes, please ask the question, please. Yeah, yeah, please.
I think my question is not far from what Anton asked. Looking at your code, your dry image, like the images that you got for the dry season, that are 20. And with that function, the median, are you out of the 20 images?
Yes.
Are you actually getting just one image from that?
Yeah.
And that's the one that you are clipping?
Yes. Yes.
Okay.
Yes. 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 Yes.
Uh-huh.
And
Alright.
from the two images, we just create the median. Just create the one median composite and click with our study area. Okay.
Yeah, okay.
Okay. So now if you check, we find out this type of image collect. But in this case, you can see it show very digital number, because it's not the we need to convert into the reflectance value, mainly a reflectance value we need to convert. So for that, this image collection have already, if you check, already have the scale value 0.01. It's a scale value, and all of bands are the same scale. You can see all of bands are the same scale. So this scale I need to multiply with all of image collection. Okay, dry season as well as also rainy season. Then I find out the reflectance value, okay, for these bands. So for that, just I multiply. So in this case, if I just multiply all of those in here, just put the multiply, suppose 0.0001, and run the code, it's create a problem. Okay, because multiply is work only for the collection, sorry, image data type. Multiply function is only work for image data type. But now this image collection stored the image collection. This variable stored the image collection. So for that, I need to create a function. I need to create a function to multiply all of images. Okay, so let's go try to create a function. So for that, I simply take a variable, suppose image rescale, and then create the function keyword, then put the element name, then curly bracket. So from this curly bracket, what I return, I want to return this element multiply with 0.0001. Okay, and then I just apply the copy properties, similar code, copy properties of this element, and apply system time start to system time int. Okay, so this is the function. So this is my collection. So now I simply copy the collection and paste here and add using the map function. Okay, just add the map function. So now what happened? So now from this collection, all of image, simply one by one, just go to this function and multiply with this value. Okay, and we find out the proper rescale images. Okay, so this thing, then further, if you check, in this case, we can also, if you want, you can just take the one variable and write the function. This function we simply connect using the one variable, only this variable, just simply adding for connecting. So just I copy the code. Okay, and this code I simply connect in here. So now this code I don't need. Okay, just I remove it. Okay, so now what happened? What's the benefit I can get from here? I just take only one variable and I create the function. Okay, and this function I simply connect with this collection. Okay, at the same time. But if you want, you can also take the new variable and create the function and further simply call it call this variable name because this variable is stored at the collection and simply connect. Both are the same process. But this step or this process is easy because I use the same variable, because further I don't change. You can see this after multiply, I don't need change anything because I use the same variable also in here. You can see for filtering the dry season, wet season. Okay, so now if I run the code, there is no problem. Okay, so now you can see just I write the function with the similar variable. Okay, but previous time we also write the function different variable, but in this case we are just use the same variable and create this function, and further is simply connecting using the map function. So now what happened? Now we find out the rescale. Basically we just find out the proper wavelength or reflectance value for each band. If you check the result now, and I want to add the color, suppose red, green and blue band, keep the stressing 98%, and now I just apply, and further just import. Okay, just copy the visualization and paste after the object name, and I put the layer name, suppose it's a dry image. So similar process, just apply and add the weight image. So just I add map dot add layer and call the weight image and run the code. So now it's added the another layer. Just add the visualization, suppose red, then green and blue. Stressing I keep 98%. And then just apply. So you can see we find out this type of imagery, and this image is not bright. It just show, you can see this type of darkness, this type of image. But previous image you can see for the dry season, it's very bright because there is no cloud. But in this cloud image you can see, find out this type of bright or dark we find out. Okay, so now we simply increase the light intensity. So for that, simply increase the gamma value. Okay, just I increase suppose some gamma value and then apply. So now you can see it also increase some light intensity, also find out this type of imagery. Okay, so then further I simply import this visualization. So now a new line of code added in my code editor. Just I copy and paste after the object name, and then put the layer name. It's a wet image or rainy image. Okay, so now if you run the code, we find out these two imagery. Now we find out these two imagery. So one image for the dry season and another image for the rainy season. If you check, we find out this type of imagery. So this is the dry image. Okay, so it's very neat and clean. There is no cloud, we find out. But you can see rainy season, we find out that this type of imagery, and we also find out this type of, you can see this type of white pixel. Basically it's a cloud. Okay, also you can see it's a cloud, this type of white pixel. We find out this type of cloud, we find out in this imagery. But this type of cloud we can also remove. Inshallah in the next class we discuss about that, how to remove the cloud, and we can get the very neat and clean satellite imagery. Okay, so we find out the two season imagery for the rainy season and dry season. So now I want to use this imagery and I want to identify water body. Suppose I want to extract the water body from this satellite imagery. So for the dry season and also wet season, I want to identify water body. Okay, for the two season I want to create, suppose I want to create the water body map in this Dhaka city where I find out the water. I want to identify water body place It can be lake or pond or any other water body reservoir I want to identify from this satellite imagery. Okay, for the both of season, rainy season and wet season. Okay, then I try to compare where I find out the water body in the rainy season or where there is no water body in the dry season. I want to compare these two imagery. So now how I can extract the water body from satellite imagery, we discuss about that. So for that, first of all, we need to use some indices. Okay, there are a lot of indices we are used to extract the water body from satellite imagery, Landsat or Sentinel. Both of satellite imagery can also use this type of indices. So if I simply search on the Google, suppose water index in remote sensing, simply go to this. So I can get some also different types of research paper also. So I simply open this link, what types of water index and their application. So we try to find out this type of things. So if you check, this is the water indices as a monitoring tool. So we find out that some indices, different types of indices. If you check this, the indices, it's called the NDWI. NDWI basically normalized difference water index. So this is one kind of a normalized difference water index, and this index basically you can check how it will be work, this type of information, and you can see this is the formula. So this is the equation. Okay, so near minus short wave infrared 2 divided by near plus short wave infrared 2. So when I apply this formula, then I can easily detect the water body. Okay, and how we can use it, you can see the monitoring the change in water content in level leaves, then analyze the susceptibility of the studies area of fires, modeling the plant fertility, reduction of the surface water. Okay, there are a lot of application. This is the one index, NDWI. Another index, if you check, it's called the WRI, water ratio index, WRI, and this is the formula about that water ratio index. Okay, so you can see studying the ecosystem physiology, then detecting water bodies in study area. So there are a lot of uses also this index WRI. And if you check the different types of rains, if the index value 0 to 1, no water on the surface, 1 to 1 2.5 plant pointing, then moisture, then 2.5 to 3.8 water bodies. Or when I use this type of index, I can easily get this type of feature, I can easily identify. Okay, also you can see this is another index, it's called the MNDWI, modified normalized difference water index, and this is the formula about that. Okay, modified water index. So you can simply use the index and then identify the normalized difference water index. You can see the uses. Okay, so you also try to read this type of things, then you can get the more better idea. So this is, they can see what normalized difference SONA index. Okay, this is the formula about that. Okay, so this type of index, not only for that, if you check some other research paper for the water body or identify for the water index, then you can easily get. So suppose you can, let me just one paper, normalized difference water index, remote sensing of vegetation liquid water from space. Or if you check, you can see the water index and water band index in precision agriculture. Okay, so you also, you can see, you can get the more better idea when you write how to connect the water index for the agriculture precision. Then you try to read this type of thing, then you can get the more better idea. Okay, how to connect, you can see that water ratio index formula. Okay, we can easily connect. So you can see this the normalized difference NAWI formula. Okay, so application, you can see mapping the open water bodies, assessing the water content in labs, monitoring the change in the water stress in vegetation. Okay, so MNDWI. Okay, you can see the normalized difference moisture index and their application. So same process. Okay, you can see. So suppose I want to use this formula. Okay, and then I want to identify water body from my satellite images, rainy season and dry season. I want to create the open water bodies map for the two season, rainy season and summer season. So I want to apply this formula, just I copy this formula. Okay, so just I simply paste this formula. Suppose I want to compute this formula, green minus near infrared divided by green plus near infrared. So this formula I want to compute, and further I want to extract the water body from two satellite imagery, rainy season and dry season. Okay, so for that, how I can compute this type of equation in Google Earth Engine? So there are a lot of way. So I will try to show you the all of way one by one. So first way is very easy. It's called the first way. It's called the normalized difference function. So it's one kind of function, normalized difference function. So if you check the function in the docs tab, simply search here normalized difference. So you can see this function I can use image. I can easily use the image ee.image data type, and I already create the two images, dry image and wet season image. I already create in my code editor. So now I can easily apply this function, normalized difference function. If you check how it will work, so just click on here. So you can see it compute the normalized difference between two bands. Okay, only two bands, only two bands. In this case, if you check green and near infrared, green and near infrared, only for the two bands. This function compute only for the two bands. And if you check, this normalized difference is computed as first minus second divided by first plus second. So when I mention the band names in here in this function, when I mention the band names, then it automatically computed as first band minus second band divided by first band plus second band. It's automatically computed. Okay, when I mention the band name in this section, in this function, then it automatically computed this type of things. So let's go try to use the function and mention the band name, then check what happened. So for that, just I take a variable. Suppose I put the variable name is ndwi, suppose dry. You can put a name dry. So now I just call the dry image, just I call, because dry image is stored in this variable, just I call the dry image, and then compute, just apply the normalized difference. Then I mention the band name. So in this case, I take the two band, green and near infrared. So just I apply the green band. If you check the band name from here, green band basically B3, and near infrared band is B8 for Sentinel 2 satellite imagery. So just I mention the band name B3 and B8. So now what happened? So now this function automatically computed B3 minus B8 divided by B3 plus B8. Okay, so it's done. So now we also computed a normalized difference in the rainy season. Okay, another season. Just I copy the same line of code and paste here, and I put the name, suppose NWI wet, and then I just call the wet image, and then paste here. So now further I simply add the layer. So take the layer, suppose map dot add layer, and call the NWI dry and run the code. So now it's added the another layer, mainly NWI dry map. We find out in here. Okay, so we find out this type of map. So now further, if you want, you can also add the color in this layer. Suppose just I click on here. Stressing suppose 98% I keep, and then add the color. Suppose where there is no water, I want to display it as a suppose I put this type of color where there is no water. Just a minute. Then suppose I use this type of color. Similar, just I try to use this type of yellow color, and then I want to use suppose this type of blue color to identify water body, then apply. So now you find out this type of blue color is the water. Okay, so just I import this visualization, just import and copy this variable name and paste after the layer name. I put it's a water body in, suppose it's dry season water body. So you find out this type of another layer to identify water body. Okay, we find out this type of place, blue color indicating about that water body area. So now I apply the same process for add the map for rainy season or wet season, same process, and apply wet, just paste and run the code. So now if you check, we just simply add the color. Suppose I want to add the same color combination, just I click on here and copy the color code, just click on the pen sign and you can see just copy all of same color. I just try to keep use. Okay, and then open this layer and click on here, and then stressing I keep suppose 98% stressing, and then apply the same color, just I paste here, and then okay, and then apply, and finally also import and copy the visualization variable name, just copy and use the name after the object name and add the layer name, suppose water in wet. So now run the code. So now you find out the 2 season water body map. We can easily identify water body from the 2 season. Yes, please.
Please, I want to know in selecting your colors, like do you assign to Google Earth Engine that blue is for water body, green is for this? How do you know that this color is for this feature?
Okay, so you can use any color, there is no problem. So but for the water body we try to use the blue color for identify for the water body. Okay, so in this case I just concern only for the water body, that's why I simply don't concern this type of feature. So I want to display and high. Okay, so this another thing is the high positive value. Okay, suppose positive value indicating about that water body. Okay, when I use it, if you check the pixel value, click on the inspector tab, you can check the pixel value just for the water, we find out the positive value. Okay, positive value we find out for this water body, you can see 0.2 0.3 positive value, but for this type of things we find out that suppose negative value. Okay, suppose it will be start this range same, suppose it will be start from -1 to +1. Okay, this is the range -1 to +1. So negative value is not the water body, but positive value it's the water body. high positive value, indicating about the high positive value, we find out. Okay, so for that I simply can see when I just add the color, so we find out this type of things. Okay, negative, and then you can just like add this type of color, so then it just make the gradient. Okay, add the gradient. Yes, please, any question? Yeah.
Do you ever consider thresholding methods?
Yeah.
Like after using the spectral indices, do you
Yeah.
also use thresholding methods?
Yeah. Okay, it also possible. We can also extract the water body from here also, no problem. So it's a map, it's a indices map. So from this indices map, we also extract the water body from this NDWI map. Okay, we can also extract the water body. Yes, please. Yeah, any question, please?
So you have just created the two different maps, for one for dry season and other one for wet season.
Yeah.
Can we compare both seasons in one map?
Yes. I just take one by
Let's
one.
say I want to compare dry
Yeah.
season with wet season in the same map
Yes.
for 1 year.
Yeah. So basically, we just identify. Suppose some place, you can check the result. If you check, suppose just I open this map, we find out this type of place is the water body in the rainy season, but dry season there is no water. If you check, in the dry season there is no water. And you can also get the more confirmation when you check the pixel value. Suppose I just click on here, in the rainy season I find out the positive value. If you check, in the rainy season we find out the very high value, high positive value, 0.7. But dry season we find out the negative 0.68. So negative means that there is no water in the dry season, but rainy season I find out the very high water. Okay, and if you check, suppose this type of place, just click on here, check, you can see there is no water in the dry season or dry time period, there is no water, but for the rainy season we find out that water body. Okay, so now how I can compare the change? Basically we want to identify in the water body, where we find out that in the rainy season, but in the dry season there is no water. We try to identify this type of place. So for that, how I can identify for the threshold value? For the threshold value, we need to create the frequency histogram. Okay, frequency histogram. From the frequency histogram, we can easily identify the values. So for that, how I can make the frequency histogram? So for the frequency histogram, we can just we need to create a chart. If you simply check the frequency histogram, just simply find out this function. It's called the UI.chart dot image.histogram. So this function. So this function UI.chart.image.histogram, it generates a chart from an image, compute the plot histogram of the values of the bands in the specific region of the image. Okay, so now we just use it for the two different season, and we try to identify threshold value for differentiate. Okay, mainly rainy season and dry season, two water bodies. So for that, take a variable. Suppose I put the variable name is, you can put any name. I put the variable name, suppose chart dry. You can put in name, and then just apply this, just paste this function, and I create a dictionary. Suppose curly bracket start and curly bracket end. So make this and put the keyword and key value. Suppose first keyword is the image. So basically which image you want to use. So in this case I just use this NWI dry. Okay, then region of interest, it's your shapefile variable name, mainly your ROI. In this case is ROI. Okay, just I use the same ROI. Resolution scale, mainly pixel size 10 meters. And then other is not mandatory, just I remove all of those, it's not needed. So now if I just print the chart dry, and I'm not, suppose it's a dry Then I can easily identify the chart. Just run it. So now in our console, it just create a chart. Okay. This similar thing we also apply for dry NWI imagery. So just I apply chart weight, and I call the weight NDWI. I already create. Just paste here, and same RY. I print, just copy and paste, and I put the print. It's a weight. So now run the code. So now I create the two different histogram for the two different season. This is the wet condition, and this is the dry condition. This is the dry season, and this is the wet season. So now if you check the values, click on here. So if you check, this is the basically it's a frequency number, and it's a reflectance value. So in this case, if you check, we find out that 0.2, or check the highest pixel value. Okay, so we find out that 0.2 is the highest value, okay, for that dry season. Okay, we find that 0.2 is the highest pixel number. Okay, and if you check zero negative, basically negative, find out the zero border. You can see the zero. Here is the zero. This is a zero. Okay, so all of those from the zero in the right side, all of pixel indicating about the water body. Okay, from the zero, you can 0 point negative is not the water, from the zero. So from the zero, all of values indicating about the water body. So if I just identify water body, suppose greater than 0.016, then I can easily get all of pixel. Okay, in the right side, it's indicating about the water body. Suppose I want to apply, suppose you can see 0, what is the, it is 0, and then you can see 0.08 or 0.016. So if I just apply these values, suppose all of values greater than 0.016, then I can easily find out all of pixel in the water body. Or if you check less than 0. From the 0, less than 0 mainly all of negative values in the left side, all of negative values, which is indicating about the non-water body. Okay, so just I separate. Suppose in this case I want to work with, suppose water body, I want to just identify water body. So for that I simply apply, suppose 0.016 these values, or you can check the another value is 0.0. So you can see the this is the 0 is the middle center, so greater than 0 or 0.008. So if I apply the 0.008 greater than 0.008, then I can easily identify all of water bodies in the dry season. Suppose I want to apply 0.008. So how I can apply? So let me show you that. So for that, I simply create a variable. Suppose it's called the water map. So take a variable, suppose dry water, and I call the dry NWI. Just a copy this variable and paste here, and apply greater than. I choose all of values greater than 0.008, or let me check again. So this value, this is the 0, negative 0.008 or 0.016. I consider 0.016, suppose 0.016. So I put all of values 0.016 or greater than equal, because it also water, greater than equal 0.016 I consider. And then I want to add the layer, suppose map dot add layer of dry water, and run the code. So now I can easily get the water body and non-water body map. Okay, so now if you check without color, we find out this type of black and white color. So this type of white place considered the water body area, and black color is the non-water body area. Okay, we simply differentiate water body. Okay, you can see This is the water body. So now same thing we also apply for dry, or if you want, you can also add the color to look more better map. Suppose I want to add the color binary class, so I put the mean is the 1 0 and max suppose 1 binary class. So then put the two color to identify water body and non-water body. Suppose where there is no water, I need to display as a gray color, and where is water, I need to display as a blue color. Okay, now run the code. So now we find out that this type of map, I put it's a water map in dry. This I put the land. So now again, so we find out this type of layer. Okay, so this type of gray color, it's indicating about that there is no water, and this type of blue color, we find out the water body map. Okay, so this is the water body map we generate from indices. Okay, so now let's check the similar concept also used for suppose second, if you check this one, and if you check the first we find out that in the dry season we find out the highest value, you can see 0.2. okay, 0.2 is the highest for the dry season. So now let's check for that rainy season, what is the highest value of water. If you check, we find out the value 0.5, 0.5 or 0.7, 0.7. You can see 0.7 is the highest value of water pixel value, we find out highest. And if you check where is the 0, 0.16, 0.016, this is 0, then 0.08, and from the greater than all of values 0.08, all of values, okay, in the right side we consider as a water body, and all of values in the left side from the 0 less than 0, all of values we consider as a non-water body. So in this case I simply apply suppose 0.08. okay, so let's try to apply. So take a variable, suppose wet water. So just I call the wet water NWI wet, and I apply suppose greater than equal 0.0008. 0.008. Yes, please. Any question, please? Any question?
Yes, I learned with the NDWI, it can represent vegetation moisture content. I want to know how do you differentiate between vegetation moisture content and then actual water body, like
Okay,
the
so
NDWI.
okay, so further we need to talk about the agricultural precision. It's a vast topic, so I am not going in this topic in this time. So you also try to read some paper regarding this type of topic, how to connect the agriculture precision to identify soil moisture or other things. Okay, because it's a vast topic. We have another online training program only for the agriculture precision. Okay. Yes, please.
I can see that you are thresholding based on the pixel values,
Yes.
other than using. There's an algorithm called O2. Is
Yeah.
that something similar, or you are just showing us how to actually pick the actual pixels?
Okay, so in this time, Otshu is also, this histogram is almost similar, not much any difference. So in the Otshu method, we need to apply different types of suppose mean, max, and then we identify. But in this case, we simply take the values from the chart, from the histogram chart, from this histogram chart, and based on the values. Suppose all of positive value greater than 0 or all of values in the right side we consider as a one class, and all of values negative value, suppose less than 0, we consider the another class. So our trees also work for this type of things to identify based on the threshold value, identify, differentiate or distinguish the classes. So in this case, not only for that, it's used lot of things to distinguish, to identify, suppose water body, vegetation, and it also use some also mineral exploration also to identify specific mineral, help of the Orshu or frequency histogram values or pixel values we identify. So in this case, we find out this type of water body map. Yes, please. Yeah, we can also measure the area. So I'll try to show you that also how to measure the area. Okay, water body, how much area. Okay, for the dry season or rainy season, we can also strip. So now we can, any question about this map, you can ask me to identify only for the water body map, help of histogram. Yes, please.
Yeah, I have a question for this water body map.
Yeah.
So what is the effective area you can work with? Can you work with the entire country right away? And if, or with the, like, can you do it for the entire Earth? And if yes, will it reduce the quality of the water map or not?
For the entire art, it also possible. We can also use it for this type of imagery because it's also available. But for that entire art, we also find out some problem because some imagery have lot of cloud, a lot of pixel. But it also possible to work with for entire art to identify water body map. It also possible using this concept. Okay, but in this case, it's the regional we try to apply for the Dhaka city boundary or a specific area of interest, and it also help you to identify water logging area. Okay, suppose in the rainy season we find out the lot of place in Dhaka city have the water logging or water logging area. So this type of place there is no water in the dry season, but rainy season we find out the water body. Okay, so this type
So
of, yeah.
do I understand correctly that if you choose a bigger region, let's say 2 countries, so 5 countries, it will not reduce the quality of water map?
No, it's not reduce the quality. We also find out the more better map, no problem. It also possible. Use the same method we can also apply. Suppose whole country boundary of Bangladesh, I want to identify water body area where have the water for the different season. Same concept we are just use.
Thank you.
Okay, so this 15 images we find out in this time we get 20 images for the dry season, and this image is available only for the season January to June. Okay, 1 to 6 this season we find out the 20 images in the year of 2024 in the 1 year. It's the 1 year for the 1 year we find out the 22 images. Okay, suppose if you increase the time period or year for the same season, then this image is also increased. So we always try to identify lowest cloud cover imagery. Okay, lowest cloud cover imagery we can also identify always, but some place for the rainy season or river bank or coastal area we face some there is no image, then we just increase the cloud level. Otherwise just we try to find out the lowest cloud cover image, very neat and clean. So now we find out the two water body map. We find out this type of map. You can see. But if you check, we find out the some place. You can see. I think it also better. I try to use the another color to identify different two season. Suppose for the rainy season, I want to apply red color to identify water body. Then you can easily identify. More better. So now you can see we find out this type of map. You can see this type of red color. We find out that rainy season water body. But if you check, it also overlay. It also overlay with our dry season. Okay, you can see this type of dry season water body we find out. Okay, but when I open the rainy season, you also find out. Okay, it's overlay. So now how I can separate? I want to identify only this type of area where there is no water in the dry season, but rainy season I have find out the water. So I want to identify this type of places in the Dhaka city boundary, and this type of place I consider as a water logging area. And this concept we also use for the flood mapping also. So you can see, suppose this type of place, this type of blue color is one kind of permanent water body. I consider this type of blue color is a permanent water body. And suppose this type of red color, suppose you can see this type of red color, I find out this type of red color, it's a flood water or water logging area. But I have also some permanent water body have also this type of place. So now how I can distinguish these things? I want to identify only for those place where there is no water in the dry season, but rainy season I find out the water. Mainly this type of place, you can see this, there is no water. Okay, there is no water. Okay, I want to identify only for this type of place. Also you can see this type of place, there is no water in the dry season, but rainy season I want to identify this type of. Okay, so I want to identify or I want to calculate how much area have the water in the rainy season, but it's not mixed with the permanent water. So this is my main goal. But you can see in this case we create the water body map, but it's overlay. Suppose you can see this type of place have the water in the dry season, and also rainy season we also find out this type of place have the water body. Okay, but now I want to distinguish. So now how I can distinguish and identify only for those place where there is no water in the dry season, but rainy season I find out the water. Okay, so let's try to explain about that. So for that we simply identify the lowest value, lowest threshold value for dry season or permanent water body. Permanent water body, I want to identify lowest NWI pixel value from the dry season. If you check, this is the dry. In the dry season, if you check, the highest value is that 0.2, 0.258 or 0.258 or 0.2. This is the highest value. Okay, this is the maximum reflectance value of NDWI in the dry season. So in this case, my threshold values I consider suppose 0.2. I can see 0.219, 0.248 or 0.266. So 0.2 or 0.266. So this is the highest value, 0.266. And if you check the wet season, in the wet season, just I open, you can check the 0.2, 0. You can see 0.2. This is a 0.2 column. And if this is a 0.2 column, all of values greater than 0.2, all of values greater than 0.2 consider as a only for rainy season water. All of values greater than 0.2. Okay, because 0.2 is the highest value for the dry season. You can see is the highest value for the dry season. But when I apply, when I check the histogram in the rainy season, I find out the 0.2. It's a 0.2, and all of values greater than 0.2 consider as a rainy season water body. And if you check, we find out the highest value for that 0.7 or 0.8 in the rainy season. So just we are use this concept, and then we identify only for rainy season water and which is not mixed with the dry season. Basically, this type of place where there is no water in the rainy season, in the dry season, but we find out the water in the rainy season. We try to identify. So let's go. So we find out the 0.2. Or just I right here. Suppose equation, I simply put this. Suppose water logging. So now I simply apply 0.2. Suppose if the NWI wet season or rainy season, it's greater than 0.2, all of values, NWI greater than 0.2, all of values consider as a only for rainy season water. And then also use the another condition, and NDWI dry less than 0.2. Okay, so now I try to apply this condition and identify only for this pixel where there is no water in the dry season. We find out only for the water in the rainy season. So let's go try to apply this condition both of images and identify this type of places. So take a variable. Suppose I put the variable name is the water area, and then I call the NWI wet. We already calculated, you can see NWI wet and NWI wet dry. So just I copy the NWI wet. These things I want to just apply the greater than 0.2 and NWI dry. We already compute the NWI dry. Less than 0.2. So now we are just applying this type of formula and we want to identify this type of place. So just add the layer map.add layer. So now it creates the map water logging area and non-water logging area. So water logging means that there is no water in the dry season, but rainy season we find out the water. This type of place. So now run the code. So now we find out this type of white color. It's indicating about the water logging area. This type of place we find out the water only for the rainy season. Okay, this type of place, white color, and this type of place indicating about that there is no water in the dry season, but rainy season we find out this type of water. Okay, only if you check. Okay, if you can also add the color to represent it more better. Suppose I want to add, okay, if you want you can also add the only for the single class. Basically it show the binary class, mainly two class. Suppose not water logging area and water logging area, we find out these two class. If you want you can just apply a function. It's called the self max function. So basically it's one kind of function. It's remove the background. It remove the background and make a single class only for the water logging area. Just create the layer only for the water logging area. So just I apply the self max and then define the color plated only for the one color. Suppose I put the color plate as a, suppose I put this type of orange color indicating about the water logging area, and this type of place there is no water in the dry season, but rainy season we find out the water. And I put it's a water. Yes, any question? Yeah, please.
I just wanted to say this is a very good technique. Does that mean, is it something similar to someone trying to show occurrence, water occurrence in one particular area?
Yes, there's similar concept.
Okay.
Yeah, it's similar concept. Now if you check, so you can see there is no background, so we can get only for this type of place. If you check, so this type of place we find out the water. Okay, this type of orange color, it indicating about the water body only for the rainy season, and this type of place there is no water in the dry season. Okay, there is no water or this type of place. And if you check the values, suppose I want to check the pixel value. I just open the NWI dry and wet and dry map. So now if you check the values, suppose just click on the next tab and click. So now you find out that the range, if you check the range, water in dry, we find out the value negative 0.63. Okay, and which is less than from 0.2. Okay, it maintains my condition which I set, and you can set, we find out the 0.8. Okay, which is greater than from 0.2. Okay, so now this type of equation or this type of values, where I find out true, then I just find out only for this type of place as a waterlogging area we just consider. So any area, if you check this type of orange color, it maintains this equation. So just check it, click on here. We find out that you can see negative 0.6 in the dry, and we set the dry less than 0.2. If the less than 0.2, we find out that values negative 0.64. Okay, which is less than from 0.2. And we find out the 0.6 in the wet season, which is greater than from 0.2 in the wet season, greater than 0.2. So it maintains this equation, and we identify this type of place have a water in rainy season, but there is no water in the dry season. Okay, any question, please? Okay, any question?
This is great.
Yeah, and there is a lot of
Are there-
uses. Yes,
Are
please.
there any? I have a quick question. So, are there any other imagery? Like, how do you know which satellite images used for which data? Like, for let's say for dry season, do you go to Copernicus or Sentinel or Modis? Are there any best
Yes.
practices?
Yes. So we always try to use high resolution satellite imagery. Okay. Suppose this type of analysis we can also do using the Landsat imagery also. No problem. Same concept, same things we can apply and also do for the Landsat. But Landsat satellite image is 30-meter pixel size, but Sentinel-2 is 10-meter pixel size. So when I use the 10-meter pixel size image, it give me more better resolution or better map or better pixel will find out when I use the 10-meter resolution. Or even if you want, you can also use the more high resolution imagery to detect different types of feature, not only for the water, anything, then we can get the more better result. But freely available, we can use the Sentinel-2 and Landsat and also Modis.
Right, but like when I try to go to search for places in data sets,
Yeah.
let's say for spectral analysis, there are so many different Sentinel data sets. Like there is a multispectral instrument level 2A and level 1C, and there is a NTRI SO2. Like there are so many different Sentinel data sets. How do you choose from these so many different data sets the one that will work the best, let's say for your application, for my application is spectral analysis for mineral exploration. Let's say for someone else, it's like water body, identifying the humidity. How do you know which one to use?
Okay, which one is okay? So basically, there is a lot of application for the different types of images. Suppose Sentinel, we find out a lot of version. If you check in the Sentinel-2, let me show you that. So Sentinel-2. So in this case, we are used at the surface reflectance level 2A, as well as we also find out that another suppose level 1C. Okay, so always we use the Sentinel-2 level 2A
What
because
is the difference between
yeah.
L2 and 1C?
Okay, I explain just a minute. So we always use the Sentinel-2
Like, would you always default to 1C or would you always default to 2A?
Yeah, basically this level 2A, it's a surface reflectance and a spectral analysis requires the surface reflectance. So when you compute the surface reflectance and spectral analysis, we use the surface reflectance always, okay, for that analysis. Suppose you want to identify spectral analysis or spectral analysis, then it's required the surface reflectance value always. Without it, not we find out the another values. And level 1C is the top of atmosphere reflectance. Level 1C data in Sentinel 2, it's the top of atmosphere reflectance. It contains the aerosol, water vapor, atmospheric scattering. Okay, we find out that aerosol influence or train environment and brightness values are not true for the surface reflectance. Okay, but when you work with the spectral analysis, a spectral analysis must require the surface reflectance. Landsat surface reflectance or Sentinel 2 surface reflectance we can use for the spectral analysis. Okay, because level 2 is it's already corrected for atmosphere using. Okay, it just already atmospheric correction already done, and surface reflectance product we can easily use for spectral signature extraction. So but level 2A it's the best for the spectral signature extraction. You can easily extract from the level 2A, as well as different types of indices, suppose NDVI, EVI, SABI, or different types of mineral exploration, different types of index we also use. So it's the best, and also used for the machine learning classification, crop health monitoring, water quality, or mineral mapping. Level 2A data is the best for that to get it. Okay, so basically we are just use the Sentinel 2 level 2A data for spectral analysis and band reflectance interpretation. Okay, always it provides the more better result. And top of atmosphere, this type of things is not better to use for surface or reflectance. It's not provide, so it's not more best to use this type of analysis for the mineral, particular for the mineral. It's not. Okay, so we always try to use the spectral signature values, use the level 2A data for the Sentinel 2, and Landsat is also available for the surface reflectance. Then you get the more better result.
Landsat will create better result than Sentinel level 8 to 2A.
No. Sentinel it's resolution. Sentinel 2 is provide the more better result because Sentinel 2 is the high resolution. Okay.
Okay, understand.
Yes. Yes, please. Yeah, any question, please?
You just mentioned that yes, you just mentioned that the Sentinel topo the 2A
Yeah.
is not the best as compared to the harmonized one. I was wondering, does that is it because of whether the images were calibrated or not?
So harmonized. Okay.
Is it
So
something
basically,
that one
okay.
can actually
So
do
basically, in
on-
Google Earth Engine, it create this type of harmonized image. Basically, it's the pre-processed, okay, with the high resolution or multispectral imaging mission. So it's create this type of ready-made product. But when you work necessarily, when you just use the Copernicus website, we can download the level 2A or level 1C. But Google Earth Engine harmonized is more better. Okay, but when you download the data from the Copernicus, then we try to use the level 2A imagery. But harmonized is also more better for the Sentinel 2.
So harmonized is
but-
better for spectral
Yes,
analysis.
yes.
Yeah, but it looks like its availability starts from 2017. If you are looking for a time series analysis work, then it means
We
you
can
are
get
sort
the
of-
data from 2017.
you
for
are
that.
going to cover a very small.
Yes.
Yes, but the other one is 2015, which means it's a lot better. All I'm asking is, with your comment about the other one being better, does that mean if I'm looking at a time series analysis, then I can, what is it that I have to do? Because
Okay.
if my study starts from
Yeah.
2015, then
Yeah, understand your question. Yeah. So basically, it's a data set availability. It also depend. Suppose when you work with the historical data analysis, suppose Landsat, it's more better when you work with the historical. Suppose 1990 or 2000 or 1980. So this type of image we find out for the Landsat. Then we are not use the Sentinel 2. Okay, so similar things. So harmonized is available from 2017. Suppose you just make the analysis between this time, then try to use the harmonized. But 2015 harmonized is not available, then you try to use only for that. Okay, but we always try to use the good quality images. But if there is no image, then we try to go Landsat, or without harmonize, we just use only for that. Okay. Okay, I hope you can got my point. Yeah. So now we try to compute the area. Suppose how much area, we find out that water logging area. So this type of orange color, how much area you find out. Okay, in the season, in the rainy season, you find out the water. So let's go try to identify the calculate the area. So in this time, we just create the pixel area, total pixel area. So for that, we always use the one function. It's called the ee.image.pixel area, ee.image.pixel area. So this function, so we can easily apply this function any image. Okay, it's called the ee.image.pixel area, and you can see this function, it return a image, not returns the value or area value. It's not return, so it's just return a image, and this image contains the is pixel. Okay, suppose it generate an image in which values of the is pixel is area of that pixel in square meter. Okay, so this function, it's not provide you the value, statistical value, but this function generate an image in which the value of each pixel is the area of that pixel is in square meter. Unit is the square meter pixel area. Okay, so we try to apply this function first and generate the image which the values of each pixel is the area of that pixel in square meter. Further, you also use the another function to compute the total area. Okay, so these are two steps when you compute the area. First step, we are just simply apply this function to generate image, and this image all pixel in the area of that pixel in square meter unit computed it, and it returns an image, and further from the image we compute the total values. So just I use the function e.image.pixel area. So take a variable, suppose area, and then apply this function ee.image.pixel area, and this it's compute the pixel area in square meter unit. Okay, but I need the result, suppose square kilometer or hectare or any specific unit. So suppose I need the result for hectare. So for the hectare, you simply multiply this value, multiply 1 into 10 inverse 4, mainly 1e minus 4. So this value simply multiply. Okay, then it convert the unit, it's compute the pixel area in its hectare unit. Okay, and then put the add bands function. So now mention here the variable name. I want to compute the area for this type of place, orange color place, or this, and this map is stored in this variable water area. Just I copy and paste here. Okay, so now it generate an image. In this image, all of pixel value, compute the pixel area in square meter, but I need the statistical value. I need to compute the total pixel area. Okay, so for that we use another function. It's called the reduce region. If you simply search reduce region, so this function we can easily apply for the image, and this function compute all the pixel in a specific region. Okay, suppose total, maximum, minimum. So this type of statistical value we can easily compute using this function. So now this function, just you connect with this image. So if you want, you can take the new variable. Suppose take a variable, suppose area value. You can put anything. So now call the area, because I already generate the image, and apply this function, and now put all of those argument one by one. So just dictionary start, curly bracket start, and curly bracket int, and then apply the reducer. So reducer, apply ee dot reducer dot sum. because I need to compute the total pixel area. And then geometry, it's your shapefile variable name, which is ROI. Then scale is the resolution or pixel size 10 meter, and others not need, just I remove. Just a remove. So now further just compute the area, print the area values. Run the code. So now if you check the value, you find out that area. So this is the total area. 29,891.62 hectare area. We find out that water. Okay, because this layer, only for this layer. Or if you want, you can also use the square kilometer unit. So for that, simply divide 1 to 10 20 to the 6 or 1 is 6. So now on the code, so now it compute the result in square kilometer unit. So if I had the 298.91 square kilometer area. Okay. Okay, so any question you can ask me, please. And all of layer we can easily export as a GOT file format. Okay. Suppose all of layer, same process. I already show you that for the first days, how second days, how to export the GOT file. Okay, so you also try to export this type of layer when you work, and further face any problem, I'll guide you. Okay, so you can try to export the satellite imagery or NWI map. Okay, then water body map, then also water logging area. So this all of layer we can easily export as a GOT file in raster format, and further we can also use the ArcGIS or QGIS software to produce the map or convert raster to vector or KML or KMZ. Okay, easily. Okay, anyone any question you can ask me, please. And this same similar concept we can also use for flood mapping. Okay, so in the flood mapping, when you identify for flood area, we try to just create the two event, suppose pre and post event of flood, and then we try to identify for flood water and permanent water body. So let's go, I try to show you that how it will work. So let me open a previous code, then I try to explain. And in the flood mapping, we are just use here the Sentinel-1 satellite imagery. Okay, and there's a lot of benefit to use the Sentinel-1 because it's a SAR data, and this SAR data is very helpful to work with flood mapping. Okay, so first of all, Sentinel-1 SAR data, why it's important to identify for flood, I try to explain, then try to show you the code how it will work, but similar concept. In the SAR data, we find out that one band, it's called the C band SAR. Okay, so Sentinel 1, this image collection, we can easily find out one band, C band SAR. This band is the 10 meter resolution, and this band information, it gathered the information day and night. Okay, day and night, both of time we find out that. And this image all weather condition work. So all weather condition, suppose for the mainly flood time, we find out the lot of cloud and we cannot get the better imagery for Landsat or Sentinel when you work to identify for flood water or flood mapping. There's a lot of clouds we find out. But whenever you use using the Sentinel-1 SAR data, this Sentinel-1 SAR data, it's not affected by flood, mainly cloud or haze. Yes, please. Yeah, any question, please?
Okay. You just introduced something that is of my interest. So you basically, since Sentinel-1 is captures images even during the night, does that mean it's the best for flood mapping
Yes, and also it also
as compared to the harmonized?
yes, yes.
Okay,
So it's best for the
thank
flood
you.
mapping, and it also work with all weather condition. Okay, suppose for the heavy cloudy or heavy snowfall or heavy all time. Okay, so there is no effect by weather, and it's perfect for flood mapping during the cloudy events. Okay, yes, please. Yeah, any question, please?
So if there are rice fields in Dhaka city,
Yeah,
so it will count them as a waterlogging area.
yeah, we also find out the waterlogging area. Basically waterlogging area we
No, no, my
can.
question is,
Yeah,
if there are rice fields which require water to grow,
yes, we find out
so
that
it will consider rice fields as waterlogging areas, is it?
yes, in the rainy season we find out the water, but dry season there is no water. Yeah, yeah. Okay, so now it's perfect for all floods during cloudy events, and we find out the smooth open water we can easily identify using this band. Basically, in the Sentinel-1 we can easily identify VV and VS, this type of bands, and very low backscatter in PV and VS because of this type of reflection we can easily identify. Suppose this type of place is the water, and it's also some limitation also for the suppose Middle East we find out this type of problem. If suppose for the sand land, sometime it reflects as a water values. So but for this type of region it also work very well, no problem. Only for the problem for the sandy land and Middle East there is not any kind of flood. But when you work with the flood in the Middle East or this type of place, for the sand land is also affected. Suppose VB and VS, this type of spectral signal is almost similar with the sand land. Okay, then it gets some problem. But otherwise other place is also okay, there is no problem. We can easily identify the water, and we can easily get the brighter backscatter for the land, mainly soil, vegetation, or urban, due to the volume of surface scattering. And flooded vegetation, we can easily identify. Mhm. So in this time we are just use the VV or VS, or VV is open more stable. Okay, this VV band is more stable to identify for the flood, but VS can be more sensitive to changes. When you work with the change detection, then VS is also sensitive, we can also use, no problem. And use the we can also use the DEM. It also create the incidence angle or slope marks from the DEM and shadow, this type of things. So let me show you the one example, it will be more better in just a minute. Okay, so let me run the code. So first of all, we need to identify the two time periods. Suppose before flood time we need to create the image for the before flood. So this is the image for the before flood, and then we also create the another, it's called the after flood. So we can see this is another after flood. Okay, so you can see the two imagery, and this type of black pixel, it's indicating about the water body. And if you compare, so you can see this type of place, we find out the permanent water body, this type of black color, it's a permanent water body. But when you open the after flood, we find out that lot of pixel, lot of water body pixel, lot of water body pixel we find out will increase. So now our main target is that we want to identify flood inundation area, okay, and also identify permanent water body area. So this is the permanent water body. If you check, just I open the before flood, you can see this type of place is the permanent water, blue color. So I just try to differentiate this type of place have the water body, mainly permanent water, it's not the flood water, okay, it's a permanent water body. And then if you check the flood water body, then we create another layer. So this type of red color, we find out that flood water body. Okay, so these things how we can easily work. So in this time we are just use only for the values, threshold values, and identify similar concept. Before we just take the image for the before flood, then take the another image for the after flood, and further we apply the threshold value to get it, this type of values if you check. And if you check the another we also filtered again. So before filtered will be before filtered image is just filter, and also after filter, because in the SAR data I have some speckle or noisy pixel. So this type of speckle or noisy pixel we are just remove or filter. Okay, so further we simply filter, and then further use these two images and identify flood and permanent water body. Yes, please.
For someone who's looking at a time series of the flooding in can that mean the same concept can be used? For example, I'm looking at 2015 to 2025, and I would want to know the flooding inundation for each year. Is that possible?
It also possible, but further we need to add the flood